In this video, I'll explain the proof of the constant function differentiation rule for vector functions. The constant function differentiation rule for vector functions states that if c is a constant vector, then the derivative of c with respect to t is equal to the zero vector. For example, if c is equal to left angle bracket 4, 2, right angle bracket, then the derivative of c with respect to t is equal to the zero vector. The zero vector has each of its components equal to 0. We can prove this rule in the following way. We let the constant vector c equal left angle bracket c1, c2, right angle bracket, where c1 is a scalar constant and c2 is a scalar constant. Next, we calculate the derivative of the constant vector c. We calculate derivatives of vector functions component by component. The components of the constant vector c are c1 and c2, so the derivative of the vector c with respect to t is equal to left angle bracket, the derivative of c1 with respect to t, the derivative of c2 with respect to t, right angle bracket. We can calculate the derivative of c1 with respect to t and the derivative of c2 with respect to t using the constant function differentiation rule for scalar functions. This rule is now shown to the right. The constant function differentiation rule for scalar functions states that if a function f of t is equal to c, a constant value, the derivative df dt is equal to the derivative of c with respect to t, which is equal to 0. c1 is a scalar constant, so the derivative of c1 with respect to t is equal to 0. c2 is also a scalar constant, so the derivative of c2 with respect to t is also equal to 0. This vector, now highlighted, has each of its components equal to 0, so this vector is the zero vector. This concludes the proof. If you found this content useful, please subscribe to the channel to receive more content. Thank you very much for watching this video. See you next video.